In this video, we're going to talk about the distance formula. The distance formula is what we use to find the distance between 2 points on a coordinate plane. And we use the formula square root of x2 minus x1 squared plus y2 minus 1 squared. So for example, if I want to find the distance between A and B, and A is at the coordinate 4, 8, and B is at the coordinate 1, 12. So we're talking about a coordinate plane here. So if I have a point at 4, 8, and then a point at 1, 12, and I want to know the distance between those 2 points, then that's what this formula is going to help me do. So I'm going to take this 1, because it's x2, right? We're going to label these x1, y1, and x2, y2. So the 1 is going to go right there. The 4 is going to go right there. Y2 is the 12. It's going to go right there. And 8 is the y1, so it's going to go right there. So it's kind of like plugging in for slope, right? When we plug in x2, x1, and y2, y1. Only the formula is a little bit different. So it would look like this: the square root of 1 minus 4 squared plus 12 minus 8 squared. So we would take 1 minus 4, which is a negative 3, and we still want to keep our parentheses, right? 12 minus 8 is 4. Okay, negative 3 times a negative 3 is a positive 9. 4 times 4 is 16. 9 plus 16 is the square root of 25, and the square root of 25 is 5. So the distance between these 2 points is 5. So here are a few examples. I want to use the distance formula to find the distance between the given points. So I want to find the distance between A and C. So these 2 points right here. Okay, so A is negative 5, negative 2, and C is negative 2, 6. So I'm going to have the square root, okay, I'm going to write out the formula, x2 minus x1 squared plus y2 minus y1 squared. Okay, so now I'm going to plug these in. Okay, this is x1, y1, x2, y2. So I have the square root of negative 2, right, that's my x2, minus negative 5, plus y2, which is 6, minus y1, which is negative 2. Okay, now just like when we plug in the slope, right, negative times a negative is a positive. Oh, I'm sorry, these are supposed to be squared. So we have negative 2 plus 5 squared plus 6 plus 2 squared. Okay, then I have the square root. Negative 2 plus 5 is 3 squared plus 8 squared. So now I have 3 times 3 is 9. 8 times 8 is 64. So now I'm going to take 64 and I'm going to add it to 9. That's going to give me 73. And now if I take the square root of 73, you're going to get a decimal. So it kind of depends on your answer, right? If we could either leave this as square root of 73 as our exact answer, or we could turn it into a decimal. And they like say they want us to round it to the nearest tenth, then we could say that it's 8.5 would be the closest answer. Okay, now let's do B and F. Okay, so B here is negative 5, 4, and F is 5, negative 1. Okay, so again, here's my formula. X2 minus x1 squared plus y2 minus y1 squared. This is x1, y1, x2, y2. So I have the square root of 5 minus a negative 5, so that's plus 5 squared, plus negative 1 minus 4 squared. So 5 plus 5 is 10, so I have 10 squared, plus negative 1 minus 4 is negative 5 squared. 10 times 10 is 100. Negative 5 times negative 5 is a positive 25. So that gives me the square root of 125. And again, when you take the square root of 125, okay, you're not going to get a whole answer. Okay, so we could either leave it as that, or if we want to round it to the nearest tenth, then we could say 11.2. Okay, so that could be our answer for that one. Now for A and F. So we have A, which is negative 5, negative 2, and F, which is 5, negative 1. So again, here's my formula. Square root of x2 minus x1 squared plus y2 minus 1 squared. Y2 minus y1 squared. This is x1, y1, x2, y2. So I have the square root of 5 minus a negative 5, so that's plus 5 squared, plus negative 1 minus a negative 2, so that's plus 2 squared. So here I have 5 plus 5, which is 10 squared, plus negative 1 plus 2 is 1 squared. 10 times 10 is 100. 1 times 1 is 1. So we have the square root of 101. Okay? And again, the square root of 101 does not have a whole number as the answer. So we can take 101 and take the square root. We can either leave it as that, or we can round this up and say that it's 10 point, and on this one, it's 10.0498. So on this one, we would probably want to round at least to the 100th spot, because we don't want to leave the answer as 10. We want to make sure we have a decimal. So we would say 10.05 as our answer for that one. On this one, it says triangle ABC has vertices O21, B05, and C45. Determine if the triangle is equilateral, isosceles, or scalene. Okay, so what we want to do is find the distance between all the points. Okay, if I have 2, 1, draw that again real quick. That's my A. Then 0, 5, 1, 2, 3, 4, 5. There's my B, 0, 5. And C is 4, 5. So here's what my triangle looks like. So I want to find the distance between all of these, and I want to see if it's equilateral, isosceles, or scalene. Okay, so if it's equilateral, all three of my distances are going to equal each other. If it's isosceles, only two of them are going to equal, and if it's scalene, none of them are going to equal each other. Okay, so the first thing I want to do is find the distance between A and B, right here. Okay, so I'm going to label this as x1, y1, and this as x2, y2. So I'm going to use my formula. I'm going to put it up here. Square root x2 minus x1 squared plus y2 minus y1 squared. Okay, so for A and B here, I'm going to plug this in. I'm going to have 0 minus 2 squared plus 5 minus 1 squared. 0 minus 2 is a negative 2 squared. 5 minus 1 is 4 squared. Negative 2 times negative 2 is a positive 4. 4 times 4 is 16. 16 plus 4 is 20, so I have square root of 20. Okay, now for this one, since we're wanting exact numbers, a square root of 20 does not have a whole number, so for this problem, we're going to leave this. So we know that this is square root of 20. Okay, now I'm going to find BC. Okay, so I'm going to label this x1, y1, and this as x2, y2. Plug this in, square root, okay, 4 minus 0 squared plus 5 minus 5 squared. 4 minus 0 is 4, so I have 4 squared. 5 minus 5 is 0, so I have 0 squared. 4 times 4 is 16. 0 times 0 is 0, so this is just square root of 16, which actually equals 4. So this distance is 4. So now we automatically know this is not going to be an equilateral triangle, right? Because we already have two different distances. So now we have to find the distance between A and C. So here's my x1, y1, x2, y2. So I have the square root of 4 minus 2 squared plus 5 minus 1 squared. 4 minus 2 is 2. We square it. 5 minus 1 is 4 squared. 2 times 2 is 4. 4 times 4 is 16. 16 plus 4 is 20. So I have square root of 20. Okay, so scaling means none of them equal each other, right? Well, we know square root of 20 equals square root of 20, right? Isosceles must be our answer because we know isosceles triangles have two equal sides. So this triangle would be isosceles. And that is how to use the distance formula.